Assalamu alaikum wa rahmatullah. Good day everyone and welcome to my YouTube channel today. In this video we will explain parallel arrangement of capacitors, which is the second kind of arrangement. The first being series arrangement we explained in the previous video. Now in this kind of arrangement, here is an important thing to take note of. It says when capacitors are arranged in parallel, the PD across them is the same, meaning the voltage across the capacitors is the same, but they store different charges. Okay, the amount of charges they store are different, but the potential difference across them is the same. Okay, I'm going to use three capacitors as usual. Let's say I have a capacitor. This is a capacitor. This is a capacitor. Okay, and then I have a connecting wire here, and I have another capacitor here, and I have another capacitor here. And now I'll connect this one to this one. Can you see this end to this end, and then this end I also connect it to this end, and this one to this end. Then I now connect this end to a positive terminal of a battery, and then the other one I connect it to the negative terminal of a battery. This voltage will be the same across the three capacitors. Okay, the PD across them is the same and is the voltage of the battery. Now if I call this one C1, this one C2, and this one C3, then as we said, the PD across them is the same. So we have V. This V is the PD across C1, the PD across C2, the PD across C3. But they store different charges. This means this one will store a charge Q1, this one will store a charge Q2, this one will store a charge Q3. Now the question is, how do we get the total capacitance, the equivalent capacitance, the effective capacitance? We start by adding the charges. The total charge Q is equal to charge stored by Q1 by C1, charge stored by the second capacitor, and charge stored by the third capacitor, and we call this equation 1. Okay, and this one is the total charge. Now remember this formula: C is equal to Q upon V, the general formula for calculating capacitance. Here I can, since what I have here are charges, I can make charge the subject of the formula here. So my Q is equal to CV, and I call this equation 2. Now if I apply this, I can apply this second formula to C1, C2, and C3. If you take the first capacitor here, the charge it stores is Q1. This is equal to its capacitance C1 times its PD. The PD is the same for both of them, so times V. And then Q2, the charge stored by the second capacitor, is equal to C2V. And then Q3, the charge stored by the third capacitor, is its capacitance value C3 multiplied by PdV. The same throughout. We don't have to write V1, V2, V3. Now, if this equation 2, we can substitute it for Q into equation 1 for the total charge. Then this V will be this C will be the total capacitance. Okay, and then Q1 we substitute C1V, Q2 we substitute C2V, Q3 we substitute C3V. Okay, look at what we have. We say from equation 1, comma, we have instead of Q here we put CV is equal to, instead of Q1, instead of Q1 we put C1V, instead of Q2 C2V, instead of Q3 C3V. Now V is common, so we can factorize V out. So C1 plus C2 plus C3, and then we factorize V out. Now you have V on both sides, so you can divide both sides by that V, and then you see that this V cancel V, so you have C, meaning total capacitance is equal to, and you have C1 plus C2 plus C3. Wow, this means that whenever you have capacitors in parallel arrangement, okay, the total capacitance is the sum of the individual capacitances. You just add them together. If you have two capacitors, add them, 3, 4, 5, add them to get the total. Okay, we are going to see a few examples on that. Look at this one. It's a problem solving on parallel arrangement of capacitors. Problem 1 says 3 capacitors, 2 microfarad, 3 microfarad, and 10 microfarad are connected in parallel. What is the effective capacitance of the combination? So solution, you have a capacitor here. You have 3 capacitors. So let's say this is the first capacitor. Okay, you can also arrange them, you can also draw it like this. You see, this is the second capacitor. Okay, this is the third capacitor. Okay, the first one 2 microfarad, the second one 8 microfarad, and the third one 10 microfarad. Okay, this is parallel arrangement of capacitors. Now, what is the effective capacitance? Simple. C is equal to C1 plus C2 plus C3, according to the formula for parallel arrangement, since they said they are connected in parallel. So you add 2 plus 8 plus 10, and then this 2 plus 8, 10, 10 plus 10, you have 20 microfarad. That's it. That's the total capacitance. With this, we have solved problem 1. Moving on, we go to problem 2. Problem 2 here says 3 capacitors, 5 microfarad, 6 microfarad, and 4 microfarad are connected in parallel. If the PD across them is this, calculate the effective capacitance, the charge stored in each capacitor. Okay, I like this one so very much. Solution. How? We have the first capacitor here. It has a capacitance value of 5 microfarad. Okay, then the charge stored Q1 we don't know. Then we have the second capacitor. This one is 6 microfarad. See, 6 microfarad. The charge stored here Q2, again we don't know. Then we have the third one, and the third one is 4 microfarad. 4 microfarad. The charge stored Q3 we don't know, but we are told that they are connected to a 50 to 50 volt source. So we connect that to a battery, positive terminal, negative terminal, and this one plus minus, this is 50, not 30. Okay, 50 volt. Okay, this is our circuit diagram. Okay, the first one says we should get the effective capacitance. Wow, total capacitance. So since they are arranged in parallel, as we are told here, in parallel, so we now say our C is equal to C1 plus C2 plus C3, and this is equal to the first one 5 plus the second one 6 plus the third one 4, and this will give us 5 plus 4, 11, 11 plus 5, 4, 15, 15 microfarad. This is the total capacitance. Then Q, sorry, this is A and B. B said we should get the charge stored in each capacitor. Okay. To get the charge stored in each capacitor, remember the PD, this 50 is your PD, is your V. Now is the PD across this one is 50 volt, the PD across this one is 50 volt, the PD across this one is 50 volt, because we say when they are connected in parallel, they have the same potential difference across them. And this is your C, this is sorry, this is your V, this is your V, this is your V, and then this is your C1, this is your C1, this is your C1. So here you can use the relationship between C, V, and Q to get your Q in each case. So for Q1, this is equal to C1 V. So this is equal to your C1 is 5 microfarad, but now you have to bring the micro 10 to the power of minus 6 times V, and your V is 50. So this is equal to 5 times 5, 25, so this is 250, and then this 10 to the power of minus 6 is micro, and the unit of charge is coulomb, so you have 250 microcoulomb. For the second one, Q2, this is equal to C2V, and this is for C2, this is 6. So 6 times 10 to the power of minus 6 times again 50, since it is the same for all of them. 6 times 5, 30, so this is 300, and then you have micro. I am maintaining this 10 to the power of minus 6 micro coulomb unit of charge. Then Q3 is equal to C3V, and this is equal to our C3 is 4 microfarad, so 4 times 10 to the power of minus 6 times 50, and this is equal to now 4 times 5, 20, this is 200. 4 times 50, 200, of course. Then micro coulomb. You see that? So the first capacitor stored a charge of 250 microcoulomb, second one 300 microcoulomb, and the third capacitor stored 200 microcoulomb when same PD is applied across them. So with this, we have come to the end of this video. I hope you understand everything. If you have any problem, let me see that on the comment section. Assalamu alaikum wa rahmatullah.